Okay, our fourth method of proof is proof by induction, and it goes in the following manner. There's a statement that you'd like to show is true for all n. So you start off by showing it's true for n equals 1, and then we show it's true, we assume it's true for n equals k, where k is any number bigger than or equal to 1. And the hard part comes in showing how that will automatically then conclude, you can conclude from that it's true for k plus 1. And then it follows then by mathematical induction that it'll be true for all n. The best way to picture this is with a visual. Think of the statements as dominoes, each one standing on its own. We start off by showing that it's true for n equals 1, that starts the chain reaction. We skip down the line somewhere later, assume it's true for n equals k, and then the hard part is showing that it will knock the next domino down, saying that it's also true for n equals k plus 1, so that we can't have some kind of a gap in between these where one would fall down and the next one wouldn't. And so if we start it and we can always knock down the next one, then in the end it's true for all n. Knocking down a domino is synonymous to showing that the statement is true for that value of n. So then it's always true. Let's take a look at an example. Our example is going to be to show that it's true for the first Our example is going to be to show that it's true, to show that you can add up the first n integers, the first n natural numbers, and that there's a formula that will give you that sum. That formula is n times n plus 1 all over 2. So we're going to prove this, where we first show is true for 1. So for n equals 1, we have 1 is equal to 1 times 1 plus 1 over 2. This is called the basis step, and this is a true statement. It's true for n equals 1. Now we can then assume that it's true for n equals k. That is to say that 1 plus 2 plus 3 all the way up to k is equal to k times k plus 1 all over 2. This is S sub k. We want to show it's true also then for k plus 1. K plus 1, if we want to take a peek at what it is, we want to show, we're going to take a peek at what we're trying to prove, that sk plus 1 is true. What that is 1 plus 2 plus 3 even k, and then the next one, k plus 1. And then on the right hand side, if I replace k by k plus 1, I get k plus 1. K plus 1 plus another 1 would be k plus 2, and that's all over 2. I want to show this. So I start from sk, that the kth statement is true. And then what I need to do is make it so that it looks like the next statement. What's the difference between sk and sk plus 1 on the left hand side? Basically, there's an extra number added. There's k plus 1 added. Well then, if we add k plus 1 to the one side, we should also add k plus 1 to the other side. So we have k times k plus 1 all over 2, this here, and we're going to add k plus 1 to that side too. So we have exactly the left hand side of sk plus 1. We just need to show that the right hand sides are the same. We can proceed. Just a little bit of algebra. We're going to see that, yes, it is true that if I add up all the way up to k plus 1, then what I can do is look at the right-hand side. Instead of trying to put the two fractions together, or to treat this, we'll treat this as two separate terms. The first with the fraction, and then after that the k plus 1. If we want to put them together, but instead of putting the fractions together, we're going to see that they both have a factor of k plus 1. And so what we're going to do is factor out k plus 1. What we get when we factor out k plus 1, from the first term we get k over 2, and from the second term we just get a 1. We took the whole thing out. Our job then is just to show that the rest of this looks like k plus 2 over 2. We have the k plus 1, we just need it to look like k plus 2 over 2, and we could do that because k over 2 plus 2 over 2 is exactly k plus 2 over 2. And so we have exactly s sub k plus 1. Just with a little bit of algebra, not much at all, we can show how s sub k then leads to the fact, s sub k being true leads to the fact that s sub k plus 1 is true. You can always knock down the next domino. And therefore we're done. So s sub n, this statement here, if we call this statement s sub n, is true for all n. And we're done. Mathematical induction.